In this section, we're going to start working on what if you're trying to find the probability of compound events, meaning not necessarily that more than one thing is happening, or it could be that, but that in what you're looking happening has two characteristics, let's just say. So here I have a Venn diagram, and Venn diagrams are awesome just for showing us what's going on. And in this Venn diagram, I have one circle stands for even numbers of 1 through 12, and the other circle stands for multiples of 3 in 1 through 12. And you'll see a couple things. First off, my odd numbers go out here, the ones that aren't parts of the multiples of 3. In the multiples of 3, I have 4. I have 3, 6, 9, and 12. In the evens, I have 2, 4, 6, 8, 10, and 12. And you notice the 6 and 12 are in here this is called the intersection. So the intersection is just saying that it's both an even and a multiple of 3, so it stands for both of them. And so here, I could talk about something like finding the probability that it is even and a multiple of 3. Or maybe I could find the probability that it's even or a multiple of 3, and both of those have different meanings. So if you're talking about even and a multiple of 3, that means it has to work for both of them. It has to both be even and a multiple of 3. So we're just looking at these numbers in here. If I'm looking at probability of even or a multiple of 3, we're saying it doesn't have to be both. So it could just be even, it could just be a multiple of 3, or it could be both. So all of this works versus for the and one, it's just in here. So these are compound events. Now, let's talk about the probability of the or, because that is the one that actually can give us a problem. Okay, so remember what I said. It could be that it's an even. So let's just shade that one pink. So we could pick any number that is in the even circle. Any of these could be a part of that probability. And then it could be that it's a multiple of 3. So it could be anything in this circle here. So here's the problem. If I'm just looking at even, I've got the numbers 2, 4, 6, 8, 10, and 12. If I'm just looking at a multiple of 3, I've got 3, 6, 9, and 12. And our problem comes in with the 6 and the 12, because those have been counted twice. So what happens is, as I'm trying to find the probability of the or, I'm taking the probability of the evens, I'm adding in the probability of the multiples of 3, but then I have a problem because when I do that, I've both taken the 6s and the 12s, and I've included those numbers twice, right? I've included them twice. They're both pink and blue. So what I need to do is I need to take it out once. And then that'll take care of that intersection part. So you're going to have to do that quite a bit when you have a probability of an or. So let me show you just the definition for that. If you're trying to find the probability of A or B, we say, well, that's going to be the probability of A plus the probability of B minus the probability of the intersection, which is A and B. So that intersection is the and. Now let me show you another notation, and it's a really weird notation, but we're going to do the probability of A or B, only instead of the or, we're going to use this U. And that just means the union of A and B. So the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B, only now instead of and, I'm going to use the upside down U, which stands for intersection of B. So you might see this notation once in a while, so just be aware of it. U means the union, that's meaning both circles together, all of this, okay? And then the intersection is just standing for, that's this one right here, the intersection is just standing for this part where they intersect, okay? Now we also have something called mutually exclusive. Mutually exclusive is when you have a Venn diagram where the circles do not overlap, such as if you're doing evens and odds. There is no number that is both even and odd, so that would be mutually exclusive. So the probability of A and B for mutually exclusive is going to be 0 because there is no intersection. And the probability of A or B is going to be the probability of A plus the probability of B. And we're going to end there because we don't have to worry about that intersection that we had a problem with before. So we're just going to end there. All right, now let's check it out in some examples. So let's look at page 724. Example 1 says, what is the probability if you're randomly selecting a card from the standard 52 deck, okay? What's the probability that it is an ace or a face card? Okay, now an ace card is not a face card, and a face card is not an ace card. So these are going to be mutually exclusive because they're not going to overlap. So all I have to do is figure out what's the probability of getting an ace plus the probability of getting a face. So the probability of getting an ace, there's 4 of them out of 52, plus the probability of getting a face card, there's 12 of those out of 52. So there's a total of 16 out of 52. If we change that into a decimal, it's 0.308. All right, let's look at example 2. Example 2 says, if you're randomly choosing a card from a deck, what's the probability that the card is a heart or a face card? All right, so by the way, one thing that I look at is if I see the word or, I know I'm adding. So I'm looking at what's the probability of getting a heart? Well, there are, a fourth of the deck is hearts, so there are 13 hearts out of 52. Plus a face card. Now there are 12, no, there's more than 12. No, there's 12. There's 12 face cards in a deck of cards, okay? But the problem with doing it this way is now I have to subtract the cards that are both a heart and a face card, which we see in that intersection there. There are 3 of those. So we have 13 plus 12 minus 3 gives us 22 out of 52, which is, as a decimal point, 423. All right, one more thing to talk about. We have to talk about compliments. Now, compliments are not talking about how pretty my hair is today. A compliment, okay, is spelled first off this way, so it's not even spelled the same way. Compliment. And basically you're saying it's not in the event. Okay? So if you know the probability of A, okay, let's say you know that, well then the probability of A complement, which a lot of times is either written with that little tick mark up in the corner, or I've also seen it with a line over the top. Okay, the probability of A complement is going to be what's not an A, so you're going to take 100% minus the probability of A, and that's going to be your complement. So let's think of an example for this. Okay, so let's say you know the probability of getting a 2 on a die is 1 out of 6. Well, then the complement of that would be probably of not getting a 2, which would be 1 minus 1/6, or 6 minus 1/6, which would be 5/6. So basically you're just saying what's left. After you take away this 1/6, what's left? You get the 5/6 left.